Okay, in this video, we're going to solve this problem right here, and so let's begin. So what I can do is just plug in infinity here and infinity here. So we end up getting infinity times tan 2 divided by infinity is like 0, so tan 0 is going to give us 0. So we have infinity times 0. So in this form right here, we can't use L'Hopital's, but what if we rearrange this? Instead, we could say we have the limit as x approaches infinity for parentheses tan. Instead of saying 2 divided by x, it doesn't really matter. I could say 2x raised to negative 1, close it, divided by. Instead of saying times x, you could divide by 1 divided by x. And I'll show you why I'm doing this. So in this form, if I plug in infinity, I get tan 2 divided by infinity, so I get tan 0, which is going to give us 0, divided by 1 divided by infinity is also 0. In this form, 0 divided by 0 allows us to use L'Hopital's rule. So I'm going to take the derivative of both the numerator and the denominator. So we have the limit as x approaches infinity 4, and the derivative of tan is secant squared, parentheses, we keep our inside piece, so 2x raised to negative 1, close it. Now this is going to involve the chain rule, so I can take the derivative of the inside piece, so times d, parentheses, 2x raised to negative 1, close it, divided by, we take the derivative of this piece. So I'm going to say d parentheses, instead of 1 divided by x, I can say I have x raised to negative 1. Close it, close it. I'm doing this because I think it's more obvious when you take the derivative of x raised to negative 1 than 1 divided by x. But if you're comfortable with both, then it doesn't really matter. So let's clean this up a little bit. We have the limit as x approaches infinity 4. So we keep our secant squared, parentheses, 2x raised to negative 1, times the derivative of this piece, we'll get negative 2x raised to negative 2, divided by, take the derivative of this piece, we get negative x raised to negative 2. Close it. Now we can clean up a little bit. So this x raised to negative 2, x raised to negative 2, it cancels out. This negative and this negative also cancels out. So let's rewrite what we have. We have the limit as x approaches infinity. 4, we have this 2, we'll put in the front. So we have 2 secant squared, parentheses, 2 times x raised to negative 1. You could say you have 2 divided by x. Close it, close it. And again, we cancel out the negative. We cancel out x raised to negative 2. And so this is what we actually have now. So now we can swap infinity for x. So we get 2 secant squared, parentheses, 2 divided by infinity is like 0. So we put a 0 right here. Now, maybe you're not completely, totally comfortable with like trig. We need to remember secant is like 1 over cosine x. So you're putting a 0 here, and cosine 0 is 1. 1 squared is also 1. And so we know this piece right here is equal to 1. So we have 2 times 1, which is just 2. And so this right here is your final answer, and that's all we need to do for this problem.